Assalamualaikum and good morning everyone. My name is Muhammad AZRI bin Mustafa Kamal. Before I explain my part, which is the web server, I would like to give a short introduction about our project, Phantom Lead Protocol Secure Quarantine Zone Implementation. This project focuses on creating a secure private virtual network using VirtualBox and Linux operating system. The network consists of one Linux server and one Linux client connected through an isolated internet network. The server is responsible for providing several services such as DHCP Server, SFTP Server, Web Server, and Database Server. The DHCP Server automatically assigns IP address to client. The SFTP Server provides secure file transfer services. The Web Server hosts an internet website, and the Database Server stores internet data. In addition, the client is not allowed to access the internet. This demonstrates network isolation, where the client can only communicate with services provided by the server. For my part, I am responsible for configuring and demonstrating the web server services.
This slide shows the VirtualBox network setup used for our server environment. The first network adapter is configured as NAT, which allows the virtual machine to access the internet through the host machine. This is important for downloading updates, installing software package, and performing system maintenance. The second network adapter is configured as internal network. This network enables communication between all virtual machines within the project environment while remaining isolated from external devices. By using both NAT and internal network adapters, the server can access the internet when required while maintaining a secure private network for inter-server communication. This setup supports the overall architecture of the Phantom Lead Protocol project. Alright, then this slide shows the network configuration for the client virtual machine. The client is connected to the internal network named INNET, which allows it to communicate with all servers within the virtual environment. Through this private network, the client can access services such as a web server, database server, DHCP server, and SFTP server. Since the client only needs to interact with the internal infrastructure and internal network connection is sufficient and helps maintain a secure and isolated environment. This slide shows the ping and isolation test performed on the client machine. First, I use the command ping 8.8.8.8 to test internet connectivity. The results show 100% package loss, which means the client cannot access external networks. This is expected because the client is connected only to the internet network. Next, I use the IP command to verify the client network configuration. The output shows that the client has been assigned the IP address, confirming that it successfully received an address from the DHCP server. This result demonstrates that the network isolation policy is working correctly while still allowing communication within the private network environment.
First, for the DHCP installation, what we do, we updated our package list, sudo apt update, and install the server using sudo apt install isc DHCP Server Y. What is the issue? The installation ended with an error job for isc DHCP server.service fail. Why did it fail? By default, when the DHCP server installs, it immediately tries to start up. However, it will always fail at this point because it hasn't been configured with a valid network interface or subnet scheme yet. The configuration file for the set2 /etc/default/isc DHCP server. This is an environmental configuration file used by Debian-based system. It defines settings that the system reads right before it launches the actual DHCP daemon process. Discrepancy note: there is a slight mismatch on this slide between the summary text and what is actually being typed in the video terminal, which is very common in student tutorials. The slide text say interfaces equal ETH2. The terminal screenshot shows interface v4 ENP0S8. The terminal screenshot shows the correct modern way to do it. Modern Linux system support IPv4 and IPv6 traffic. For the third step, the terminal screenshot shows the successful execution of these commands. Here are the keys details to look for in the output. Active running. The green text indicate that the DHCP server successfully started up and is currently running active in the background without crashing. For the task 1, memory 5.0M shows the system resources the service is currently utilizing. The logs bottom section, it specifies the version Internet System Consortium DHCP Server 4.4.1. Listening on LPF ENP0S8. This is crucial. It shows that the DHCP server is actively listening for incoming requests on a network interface named ENP0S8 at the IP address 192.168.1.254. Started DHCP server. The final line confirms system D successfully managed the process. For the last one, the slide highlights two specific commands used to manage the server. Sudo systemctl restart ISC DHCP server. Sudo runs the command with administrative root privilege. Systemctl restart tells the system's service manager, system and system D to stop and immediately start the service again. This forces the server to reload its configuration files like dhcpd.config. ISC DHCP server, the name of the specific DHCP server software package being used, Internet System Consortium DHCP. Sudo systemctl status ISC DHCP server. This checks the current operational state of service to verify that the restart was successful and didn't run into any errors.
Hello everyone, I am Muhammad Shafiq bin Aziz with metric number B0325-10734. So today I will be presenting the SFTP server configuration. So for step 1, we installed the SFTP service using the OpenSSH-server package. This is to ensure that our file transfers are fully encrypted and secure. For step 2, we configured the security settings. Inside the sshd_config file, we specifically bound the listen address to our internal server IP, which is 192.168.1.254, and enable the internal SFTP subsystem to strictly prevent external access. Moving on to step 3, we created a dedicated user named researcher for this service, and after that we use the ss command to verify, and as you can see, the SSH service is actively running and listening on port 22. And finally, for step 4, we conducted the client isolation testing. We successfully established a secure remote connection from the isolated client VM. You will notice a file not found error during the put and get commands, simply because we missed creating the test.txt file beforehand. Sorry for that mistake. However, the secure remote connection itself is proven to be working perfectly. Thank you.
Back to my part, I configured the web server service using Apache 2. The purpose of these services is to host an internal website that can only be accessed by devices within the internal network. According to the project requirement, the web server must listen only on IP address 168.1.254 and port 80. For the first step, install Apache. First, I update the package repository using the command sudo apt update. This ensures that the system has the latest package information. Next, I install Apache 2 using command sudo apt install Apache 2 -5. This command install Apache and all required dependency automatically. Step 2. Configure port binding. After installation, I open the Apache port configuring file using sudo nano /etc/apache2/port.conf. I change the default setting from listen 80 to listen 192.168.1.254 This ensures that the web server listen only on Internet Network interface. Step 3. Configure virtual host. Next, I edited the default virtual host configuration file using sudo nano /etc/apache2/site-available-000-default.conf. I change virtual host star /80 to virtual host star 192.168.1.254 This restricts access to web services, so it is available only through the internet network. Step 4. Create the web page. I created a simple HTML page using sudo nano /var/www/html/index.html. The page contains a welcome message indicating the user is connected to the internal portal. This page will be displayed whenever a client accesses the web server. Step 5. Restart and verify Apache. After completing all configuration, I restart the Apache service using command sudo systemctl restart Apache 2. This applies all the changes made to the configuration files. Then, to verify configuration, I use command sudo ss-tlnp bar-grep ;80. The output shows that Apache is listening on 192.168.1.254 This confirms that the web server is correctly bound to the internet network as required. Finally, the last step, client testing. I tested the web server from the client machine using command curl http //192.168.1.254. The HTML content was displayed successfully, proving that the client can access the internet web portal. This confirms that the web server service is functioning correctly.
Hello, my name is Muhammad HARYTH. Alright, at this stage, I run the command sudo mysql secure installation to secure the MariaDB server. This script helps improve the security of the database by configuring important settings such as the root word password, removing anonymous user, disabling remote root login, and deleting the test database. The system first asks for the current root password since MariaDB was just installed and no root password has been set yet. I simply press enter to continue. First, I update the DPM package repository using the command sudo apt update. This ensures the system retrieves the latest package information before installing any software. Next, I install MariaDB server using the command sudo apt install MariaDB server. The negative white option automatically confirms the installation process without requiring manual input. During the installation, Debian downloads and installs MariaDB along with all required dependencies, including the MariaDB client, server core, libraries, and supporting package. Once installation is complete successfully, the MariaDB database service is ready for configuration and can be secure using the mysql secure installation command. After launching mysql secure installation, I begin securing the MariaDB server. First, I press enter because no root password has been configured yet. The script then asks whether to switch to unit sockets authentication and change the root password. Since the root account is already protected, I select no for both options. Next, I remove anonymous users by selecting yes. This prevents unauthorized users from accessing the database without a valid account. I also disable remote root login by selecting yes, ensuring that the root account can only log in locally and cannot be accessed over the web. over the network. Finally, I remove the default test database and its privilege by selecting yes. This database is intended only for testing and should be deleted in a production environment to improve security. These steps help harden the MariaDB installation and reduce potential. Next, I configure the MariaDB server settings by editing the 50server.cnf configuration file using the nano text editor. Here, I modify the bind address parameter and set it to 192.168.1.254, which is the IP address of the database server. By default, MariaDB only accepts connection from localhost. Changing the byte address allows authorized device on the network, such as the web server, to connect to the database remotely. This configuration is important because the database server needs to communicate with other servers within the project infrastructure while still maintaining control access. After configuring the MariaDB server, I log into the MariaDB console and begin creating the project database. First, I create a new database called Phantom Link using the create database command. Then, I select it as the active database using the use Phantom Link command. Next, I create a table named sensitive data to store information about confidential files. The table contains an auto-incrementing ID, a file name field, and an upload timestamp that records when the data is added. To test the database, I insert sample records such as blueprint, PDF, and prototype schema docs. After that, I create a dedicated user account called internal user and restrict access to the device within the 192.168.1.x network. This improves security by limiting who can connect to the database. I then grant the necessary privilege to this user on the Phantom Link database and execute flush privilege to apply the change immediately. Finally, I exit the MariaDB console. At this point, the database, table structure, sample data, and user permissions have been successfully configured. Finally, I verify the database server configuration. First, I check that MariaDB is listening on port 3306 and bound to IP address 192.168.1.254. Then I query the sensitive data table in the Phantom Link database. The return records confirm that the database table and store data are all functioning correctly. This completes the database server deployment and testing process. In this step, I test remote access to the MariaDB server using the account that was created early. I connect using the command mysql.h 192.168.1.254 internal user, where -h specifies the database server IP address. -u specify the username and -p prompt for the password. After entering the password, the MariaDB monitor opens successfully, confirming that the internal user account can connect to the database server remotely. This test verified that the database service is accessible over the network and that the user permission and network configuration have been configured correctly.
In conclusion, our project was successfully completed by setting up a secure private virtual network using VirtualBox and Linux. Throughout this project, we successfully configured and tested all required services, including DHCP, SFTP, web server, and database server. We also verified that all services were accessible only through the internal network using the IP address 192.168.1.254, while the client remained isolated from the internet. This project has helped us gain more practical experience in Linux server administration, network configuration, service deployment, and system security. Overall, the project successfully achieved its objective and creating a secure and isolated network environment for everyone.